Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so we have the situation here is we have a loop, and then we have a wire tangent to the loop, which means that the top of the loop, or the middle of the loop, coincides with the top of the top of the loop coincides with the long wire. Now, the reason they say it's a long wire is because we don't need to worry about the endpoints, where this continues on to we don't know where. And what that means is each side affects points close to it symmetrically, whereas if one was shorter, we'd have to worry about different magnetic fields from each side, but that's not the case. We have an extremely long wire compared to the loop. So everything is symmetrical, which means for the wire, I'll abbreviate the wire with W and the loop with L. For the wire, we have our magnetic field is equal to B, which the magnetic field is equal to, we have mu naught times the current divided by 2 pi, 2 pi r. And r is the distance from the wire. In this case, we are told that at the center of this loop, we have no magnetic field. The magnetic field here is 0. So now, how would we get that? So let's pick a direction. It doesn't matter which direction for our current. We have the current in red, we'll say is flowing to the right in the wire. So by the right-hand rule, magnetic field has to go around like so. And that goes underneath. So that's how that curls around. So that means at this point here, which is straight perpendicular from the wire, the magnetic field is going to be pointing into the page. So the magnetic field is going into the page here. And that's from the wire, so that's BW. Now we have the loop here. If we had the current in the loop going the same direction as the wire here, this would create a magnetic field in the same direction, going into the page. But we're told that the magnetic field is 0, which means it has to be going in the opposite direction. So we have our current, let's keep it consistent here. We have our current flowing around counterclockwise, which means the magnetic field from the loop, BL, is flowing into the page by the right-hand rule. So for these to cancel, the magnetic fields have to be equal. And we have another equation for the magnetic field from a loop. Let's call this, well, let's go right here. The loop, we have the magnetic field is equal to, once again, B. We can label these. But because these have to cancel, we can set the magnetic fields equal to each other. Let's double line that just so it doesn't get mixed up with our equation. So we have magnetic field from the loop is equal to mu naught times I divided by 2r, where r is the radius of the loop. And because this line is tangent to this loop, they coincide at the same point. So this distance r is the same in both cases. It's the same R. So now, because these magnetic fields cancel, we can set these two equations equal to each other. So if we write them out, we have the left-hand side. It doesn't matter which one you put on which side, because they're both equal. We have, now this I is from the wire. I'm going to put the wire on the left-hand side. And we are given the wire. That's one of the parameters for the problem, is we know the current in the wire. This I is known. This is divided by 2 pi r. Now the loop on the other side, B is equal to mu naught times the current in the loop, which we don't know. That's what we need to find, is the current in the loop, divided by 2r. So these equations are almost similar. Everything that we have in the same spot on the other side we can cancel. So we have a mu naught on each side, we can cancel those. We have a 2 on each side, we can cancel those. And we have this r. So we've eliminated everything on the side with the IL, the current in the loop. I'm going to rewrite that with that on the left-hand side. The current in the loop is equal to what's left. In which case we have the current in the wire divided by pi. This is I wire, which is simply the difference in these two equations. As you can see, the BL here is missing this pi, which is where it comes from here. Otherwise, these equations are identical. And this will give you the current. It doesn't ask for direction, but what we can say about direction is we aren't told directions for any of these currents. But we do know that the current in the wire has to be pointing opposite to the current in the loop at the same point here where they coincide. So if the loop was pointing clockwise, or it was directed clockwise, the wire would have a current flowing to the left. And this will give you your answer here.